Hello all, welcome to the tutorial on power analysis. I'll introduce you to power analysis. What are the basic terminologies? What is the main motivation? Why do we do it? What are the main goals? What are the challenges in embedded systems? How do we test it? What are the metrics for different architectures? This will be a series of videos, but in the first video I will just cover the basic terminologies that are required to do power analysis. We start with the basic terminologies. I want you to take a very close look at this picture. It sums up the basic terminologies that are very essential to understand power analysis. You must have come across volt, ohm, amps, charge, power, watt, but how are they related? If you take a look at this picture, for example, the volt is pushing the amps to this, and the ohm is trying to give resistance, it's tying the amp guy. So those are the basic units that are required to understand. So the volt, the more he pushes the amps, the more amps will go out of, will flow out. The less this ohm is trying to tie this amp guy, he will be more able to move more freely. The more the amp flows, more work it can do. So there are three unit blocks. Once we see the terminologies, again we will come back and revisit this picture. But this picture is worth 1,000 words, and it is very essential for you to understand what really takes place. Now, the first unit is charge. What is a charge? Charge is nothing but you have charge. Okay, think of it as, for example, the money that you have. Okay, that is your charge. For example, it's very important in battery capacity. Okay, if you want to tell me what's the capacity of your battery, you say how much charge is it holding. What are its units? Its units are coulombs. Now, closely related to charge, there are certain units that you can derive from it. The main things being current, which we saw amps below, voltage, and we want to store it. How do we store it? Let's take current. What are its units? Its unit is ampere, or if it's very, very less ampere, you can call it milliampere. What is milli? Milli is 1,000 of an ampere. Okay? Let us take some example. For example, let's say you get your salary and you want to spend money. Amount of money you spend per second can be thought of as current. Okay? So, if I take charge as money, the current is how much money do you spend per second. That is what is current. What is its definition? The definition is charge flowing per unit time. That is correct. Okay? Next you have voltage. What is voltage? The unit is volt. If it is very less, you can also record it in millivolt. What is an example of voltage? Example of voltage is, for example, you can think of it as if the water is in a tank. It can be, there is a potential difference between something that is on the first floor water, second floor, third floor. If you have your tank at very high overhead tank, it is a low voltage. It's a potential difference between these two. Or again, taking an example of the analogy that we have taken, you can think of voltage as you give some money and get it back. So the net money has some potential difference, right, by which you can do something. You can buy something, etc. That can be thought of as a voltage. Okay? In the example of your water example, it is if there is a water tank on the first floor, it has some potential potential, you can go to the ground floor. If you build it on the second floor, third floor, fourth floor, if you build it very more higher, very more energy it is going to have. So the potential difference between them is what is voltage. Okay? And when you want to really store the charge, generally how much charge can I store? Okay, so the charge that I can store as is also a very important concept in your charge. Now let us go to the a very important concept called power. It is measured in watts. What is power? We have to understand this very well. Let's say you go to a grocery store. You have a bag. Now if I ask you, hey, can you lift this bag? You say, yeah, I can lift it. No, that is the power. I ask you, do you have power? Okay, think of it. I'm giving you examples where you can really think of it in a very intuitive way. So you can say, yeah, oh, this I can't lift. Oh, this I can lift. So power is at that instant. Okay, can you lift or not? So it is energy per unit time. Okay, what is its definition in terms of current? It is, if you take that example, how much is the voltage I have applied, how much is the current flowing. That is what is power. Okay, the important part is here. If you are lifting a grocery bag, if I ask you at that instant, can you lift it? You lift it and show me and say, yeah, I can lift it. So more power you have, more weight that you can lift. That is important. It is energy per unit time. Next you have something called energy. What is its unit? It's called watt hour. If it is small, you call it milliwatt, etc. But generally it is watt hour. What is it? It's an energy. It is power multiplied by time. What is an example now? Suppose I say, hey, you are lifting this bag from the grocery store. Can you walk 1 kilometer with it? You say, oh, I don't have so much energy. I can walk maybe 10 feet. Then I have to call a cab. Oh, no, I can walk 20 feet. I can walk 1 kilometer with it. So you have to lift it and walk for how much time? Then I can tell you, oh, 20 kilo bag you are lifting for 1 hour. 20 kilogram hour. Think of it. I'm giving you an example where you can think of. It gives you an indirect measure of how much is the energy you are expending. Okay. So what is power? They offer 1 hour. If you do that one, it tells you how much is your watt hour. Get the idea, right? What is the energy you need to spend to lift the grocery bag for 1 hour? What are other units that you have for energy? Think of it. Where are its applications? See, the energy bill you get in your home, right, is generally in units. What is that unit? It is watt hour. So I have 1 unit for 1 hour. Or you can have 2 units for 1 hour. I can have 100 units for 1 hour. Okay, so it is multiplied. It is multiplication. How much energy? Okay, it is not watt by hour. It is watt hour is what. How much is the energy you are expending for that duration in 1 hour? Get the idea, right? That's your watt hour. This is what are the units, energy units. Now what is resistance? Resistance is opposition to flow. What are its units? It's milliohms is what you get. So again come back to this picture now. So the volt, you need to apply voltage for something to flow. That's the reason you have a battery or you connect to a power source. Why? Because one of the wire is at a higher potential, one is at a lower, so it will push certain current through it. And this amp is how much is the charge flowing per unit time. Now there is going to be a resistance. Why resistance? Because nature is that way. It can offer resistance. Less resistance you have, more current can flow. If there is resistance, what will happen? It depends. It can be dissipated as heat. It can be dissipated if you put it in a speaker. It can be sound. So there is some resistance, right? Now if somebody says, hey, what is the power? It depends on how much voltage is applied into how much is the amp flowing. You multiply those two guys, that gives you volt amp. This is power, energy per unit time. Now if this guy is pushing this guy for 1 hour, then I get volt amp hour. That is what is watt hour. example, now take the battery. If you take the specification of battery, normal mobile battery will be 3000 milliampere hour. Means what? That is the charge that it can hold. So milliamp is what? This milliamp for 1 hour if it keeps flowing. If I measure into how much is this guy flowing or how many guys are flowing in 1 hour, then you are going to say, hey, so many guys are flowing in 1 hour, right? That is what is the charge that it stores. You get the idea, right? So this is the basic terminology. In the later videos, I'm going to introduce you to the motivation, I'll introduce you to the main goals, I'll give you how do you test, okay, and during design how do you test, during development how do you test, during your testing phase how do you test, during deployment in field how do you test, what are the metrics for your Intel architecture, what are the metrics, for ARM what are the metrics, for communication modules what are the metrics, what are the challenges that you find in embedded system for microcontrollers and microprocessor with respect to power. These are the things that we are going to discuss in the coming videos.